Dr. Sumita Sharma is a postdoc researcher in human-computer interaction at CI with a focus on empowerment, inclusion, and accessibility using interactive and novel technologies for and with children and underserved user groups. In her work, she employs design fiction with a diverse set of participants and in diverse contexts through projects with schools and workshops with adults, creating diverse approaches for designing for the future. She is currently working on a postdoc project on participatory AI with school children funded by the Academy of Finland. Over to you, Sumita Sharma, for the wonderful presentation.
Yes, thank you, Pranjal. Just to mention really quickly, I think in the schedule, it was Aya's talk right now. Sorry, Aya, I just jumped in. Must be something with the slides. So I hope it's okay if I can continue. I'm sorry about that.
Sorry, this was my mistake.
Yeah, no worries. Okay, let me do this quickly. Sorry about that, Aya. Okay. Okay, I'm sharing my screen. And yes, so thank you, Pranjal, for the introduction. Thank you so much, everybody, to participate in the seminar. And yeah, so there's been such great presentations already and so many discussions on ethical AI and lots of inspiration. I'm so inspired by all the speakers today, so thank you to them. And it's difficult to follow such great talks, and I know there's a great one coming right after mine by Aya, but let me try give a few examples and discuss about designing ethical AI for children. So before I begin, I'd like you to imagine your last year of school, like being a senior in high school, a student in 12th grade. And as you might remember, you probably had some kind of standardized test that year, a very important test that determined for many of us where and what we studied further. For example, which courses you were able to take in college or university, and maybe even which college we were able to get admission in. So it was very stressful, I know, so I'm sorry to remind all of you about that. I had the 12th board exams in India myself, and I know it was very, very stressful. But I'd like us to all go back there and think about having those exams and think about having those exams canceled because of a pandemic, because as we have seen in 2020, yes, that happens. Of course, there's some relief, but it's also very confusing. Like, how are your grades going to be determined? How are marks going to be assigned for those very sort of important, crucial standardized tests? I guess the most logical would be to extrapolate student performance. So your performance through your previous examination results, some sort of mock exams for the standardized test, other grade level exams. Does that sound fair? I guess it does, but maybe you could have had a bad day in one of the previous tests, and now that bad day grade will haunt you for the rest of your life. Or maybe your past performance is averaged with a score given by your teachers, who could then highlight students who have improved since the last bunch of exams. Does that sound fair? I think somewhat, especially given the exceptional circumstances of a pandemic. But now think, what if another parameter was added? What if to this individual score, your own performance and your teacher's evaluation of your performance, another parameter was added, like school's distribution of grades? So like a school performance or the school ranking. What do you think happens now to grades of students in different types of schools, say private schools versus public schools that have low resources? What if all these parameters are used by an AI algorithm to give you your final sort of 12th grade standardized testing score? Well, I have some good news and some bad news. The good news is you don't have to examine it. You don't have to imagine. This is exactly what happened in the UK earlier this year with the A levels. Based on these three parameters, an algorithm graded students. And as you might have imagined, there's bad news. It did not go so well. Grades of students in private schools were bumped up, and those in low resource public schools were downgraded considerably. When that historical grade distribution of schools, so some kind of school ranking, was taken into account. By some stats, it was almost 40% of students who were downgraded. There was a huge uproar, and the AI-generated grades were reversed to those predicted by teachers. So yes, reality can be stranger than fiction, and employing AI with children is not inconsequential. So we really need to examine ethical AI design for and with children, as we can see by this actual real world case. Now, there's been a lot of talk about ethical AI, and there are very many ways to approach this, as detailed quite well in Nitin's talk. And also we've heard from others, from Oti, from UNICEF, and also from Dilrukshi. So there are all these terms that we've been talking about: explainable, trustworthy, fair, transparent. And the gist is to define what is right and what is wrong, and to design for fair outcomes. So my focus in my work has been on fairness. Now, what happens is that fairness is a multifaceted concept. And from the perspective of AI, it can be considered as a combination of legal and policy frameworks that guide technology design and application in the public and private sector. And Oti spoke a lot about that from the child's right perspective and from the human rights perspective. Fairness can also be thought of from a data point of view, as large amounts of data are used to train AI systems, and that data can have parameters that display biases or discrimination. For instance, in the case of the student assessment example, the school performance or ranking was a loaded parameter. It perpetuated existing social biases and historical discrimination against specific socioeconomic groups and in the opportunities available to them. Thus, the concept of fairness and representation, inclusion, equity are applicable in a statistical sense to the data. Then there's the sort of technical or engineering perspective. What is the algorithm being designed for in the first place? And what if it propagates existing discriminatory practices through that design? Or what is feasible and possible to design from a purely technical perspective? Then there's the socio-cultural concept of fairness. For instance, what is considered fair in one culture might not be another, or even practices in different organizations or research units might be different. So what is considered unfair, say with regards to paper authorship, may not be fair in another. So when our own socio-cultural concept of fairness is so socio-cultural, then how do we design fair practices for AI used across the world? And with AI applications increasingly being designed for children, directly as in the case of UK A-levels, or indirectly when considering access to social services and public services based on household parameters like household income or area PIN code, there is a need to consider the ethical aspects and practices. My research focuses on the sociocultural aspect of fairness when designing for children, when designing AI for and with children. Oh, yeah. When considering AI for children, this is like a very sort of high-level categorization of the types of AI systems that are currently in use. And this classification is actually from the UNICEF's AI policy for children that was released last year. And as Oti mentioned, there's a new version coming up next month. So the classifications are recommendation systems, robots and chatbots, and algorithms that are used for decision-making. So recommendation systems, and I'd like to club together also online searches with this, are basically those algorithms that work behind the scene. They're invisible algorithms that decide, for example, which results to show you based on your search terms, which can be a combination of your location, previous search history, or other profile information that the search engine has of your device or your login. Or when you watch a video on YouTube and the right-hand side shows a list of other videos you might be potentially interested in, again, it's based on your searches and other profile information. Now, there are many elements to this. For instance, the idea with recommendation is to keep viewers engaged for as long as possible, which can sometimes mean that kids spend hours online watching videos, and it can also have other awful consequences. The problem is these recommendation systems are black boxes, and thus difficult to know how they work and how to mitigate the issues that come with them. I encourage you to check out the work by other child-computer interaction researchers on designing recommendation systems for children. It's called the KidRec, and there's been a series of workshops since 2017 where researchers from across the world have been discussing issues regarding children's recommendation systems. Then there are interactive or conversational AIs like robots and chatbots, and they, like I said, are interactive and very visible. Many types of robots are making their way into the classroom as teachers, as assistants, peers, tutors, or even programmable toys. And there are also chatbots to help children navigate challenging experiences in their everyday lives. We have one amazing case study on this right after this talk. Challenges with conversational AIs include, again, amplifying existing social biases, like gender bias. For example, why are most AI assistants with female voices? And this is worrying because studies have shown that children anthropomorphize robots, assigning robots various types of human characteristics and roles. And these gender biases are then perpetuated and amplified. Lastly, there's algorithmic decision-making. Again, a black box of sorts, an invisible behind-the-scenes entity using data to make decisions that can sometimes be quite crucial, as we saw in the example of the UK A-levels. The algorithm was deciding the future careers and fate of teenagers, and in doing so, amplified existing social biases. There was a huge uproar against these grades, and they were reversed. But this does not mean it won't happen again in some other context or country, and the results might not be the same. So why is it so challenging to design ethical AI for children? And that what has been mentioned already in great detail in previous talks is that not one person or group has the expertise to actually implement it. There's a distributed expertise. For instance, the technical team designing the algorithm is solving technical and engineering problems and may not be well versed in existing societal biases or challenges, which are examined from a socio-logical perspective, say within HCI or other disciplines. While there are policy frameworks on ethical AI, and we were introduced to several of them today, these frameworks are guidelines that can be quite broad from an implementation perspective. And further, not everyone contributing to the AI system would be aware of them. I'd like to give you one example of this from my own research on an AI-based therapy application for young children with autism. So before I begin, just a quick intro to what is autism. Autism is a neurodevelopmental disorder.
Call into the Zoom link, or you can use the Facebook link.
Hi, sorry, I don't see anything because I'm sharing my screen, but is somebody talking to me or there's like a conversation in the background?
There was a conversation. Sorry, you may continue.
Yeah, no problems. Okay, so yeah, just a quick recap on
Collaborate.
Autism is a neurodevelopmental disorder characterizes
Oh, but I don't have Slack on my phone.
In social interaction and communication, which can have where children can have restricted repetitive behaviors with or without accompanying intellectual impairment. And autism is understood on a spectrum. So you can have children who are very high functioning to medium to low functioning. And it's used as an umbrella term. The experience of autism is influenced by the cultural, social, and economic aspects of a place and thus varies widely across the world. And when I say the experience of autism, I mean children and adults who have autism and how their day-to-day experiences are, and also their family and parents and peers and teachers, and how everybody experiences or has opportunities when it comes to autism interventions and therapies. So the experience of autism is influenced by lifestyle, incorporating family structure, linguistic environment, and religion, socio-technical infrastructure consisting of technology and civic infrastructure, and program and services that are available, and monetary and informational resources accessible to individuals and their family. And all of this varies across the world. The context of my work is in India, where resources can be very limited, and even information and awareness can be very limited. So let's talk about AI-based therapy intervention. So I have been working with a startup in India, where we've been conducting interviews to understand how to design ethical AI in the context of AI-based therapy interventions for young children with autism. So the startup has an application that is using specific behavioral therapies to provide customized therapy plans for children with day-to-day targets and goals. For instance, for learning how to match objects, you could start with a target of matching shapes one day and then practicing them, say, 3 times a day. And then on day 2, you would practice the same shape matching and then adding another dimension to the task, say color. And likewise, you would increase the level of complexity every day while ensuring previous levels are revised periodically. This is just a very simple example of what the application offers, but it's very customized behavioral therapy for children with autism and very young children, 5 to 7 years old. So through the app, parents have access to a human therapist who provides online therapy to the child and the parents once or twice a week for an hour. And they use the app to collect all this data about how successful the child was in mapping these shapes or doing the task for that day. So both the therapist and the parents mark the child's progress to the app in various types of assessment forms, and the application, based on the assessment of the child's performance, recommends the next set of target scales. These recommendations are given to a therapist who then has to accept or reject them. So there is a human in the loop. The AI makes these suggestions or recommendations on the type of therapy and targets, but the human therapist has the final say. As already mentioned, there are so many types of different stakeholders involved in the everyday life of a child, especially in the case of a child with special needs. So here you can see a figure which kind of tries to explain these different stakeholders. So we have the children at the center, and then we have the sort of everyday adults and other humans that the children meet, like doctors and therapists, educators, other family members, their parents, and in some cases, researchers working with schools or working on these specific interventions. And these adults are actually parts of schools, universities, startups, NGOs, clinics. So that's like the second level of influence that's indirectly affecting the children through these different stakeholders that are around them. And at the final level, we have the Ministry of Human Resources and Development, just to showcase how at the policy level, at the ministerial level, at the government level, there can be rules and regulation that also dictate the experience of autism and what's available to the different stakeholders. So as you can see, there are many different stakeholders involved in designing and using an application too. Technology is going to cut across all of these different stakeholders and levels. All have their specific roles with regards to the child for whom the application is designed. But wait, the child is too young to use this specific application that I'm talking about. So it's kind of like the parents or the other family members are the real end users. And they should know how the application works. For the parents, there's no direct interaction with the AI, but they should still know the parts of the application that utilize AI for transparency, and so should the children. For the therapist, they should be able to trust the AI, that the suggestions provided for those recommendations, that they follow some protocols, that the AI was designed and implemented with a technical team in collaboration with the therapist and clinic managers, who are two different groups of people who had to build a shared vocabulary to be able to work together. They had to discuss and agree on what is possible to implement from a technical perspective and what's not possible. So while this app, you can see already, it's for young children with autism, which is used by the parents, and it's actually a tool for therapists to impart state-of-the-art interventions for autism. And if we consider it from a socio-cultural perspective of fairness, we already have three very intertwined stakeholders: children, their parents, and their therapist, who all need to be considered. So as I mentioned, we are looking at human agency in this context, and we have three very different human stakeholders to design for. So this is one example of how things get really complex very quickly. One thing I wanted to mention is when we also talk about designing AI with children, we also should look at children's role in the technology design. And this is a very famous picture by a very prominent researcher in child-computer interaction, Alison Druin, who talks about 4 different roles that children have in the design of technology. So they can be as users, so not really having a say in the design or actually even the use of the app in some cases, as we saw in the previous case where the app was technically for children, but not really used by the children, or it was used by the children and their parents. Children can be there as a tester. So when the application is designed and ready, but they could test certain usability and user experience features, usability features and user experience, and guide or change the application in some ways. They can be involved in technology design as informants, where they are included before the final application implementation, and they can inform their opinions or experiences for certain elements and features. Or then as co-designers or design partners, where they're involved in the design process at some point quite early and can influence several aspects of the design of the application. So here it is, how children can kind of take part in technology design in different levels. But we should also consider that they can also be child-led designs, where children take on a more leadership role and motivate the design from the start. They are involved in the design of the application as experts of their own lived experiences. And it's important for us to involve children as co-designers, co-researchers, or even as the experts and leaders in the context of AI for children. So issue around the ethics of AI should be discussed with children, and it's for various different reasons. Definitely to improve their AI literacy, to let them know that algorithms and technology can make mistakes, to make them informed citizens, to impart critical skills and critical thinking towards technology design and use, and together reimagine a more fair and equitable technology future, as there are going to be technology designers and makers in the future. And I want to link this to Nitin's talk and sort of his idea of thinking about the future of not just children and technology, but also the future of the world and our planet and our environment. So that's why it's really important to already include children in the design of new AI, especially when it's directly involved, when it directly impacts them. So I just wanted to introduce this new project that I've started working on, which is to realize this goal of ethical AI for and with children. And it's called the PIES project, Participatory AI with School Children. It takes a participatory approach to designing AI with school children. It's a 3-year project that started last month and is funded by the Academy of Finland. So in this project, through participatory design workshops, children aged 9 to 12 years will design AIs of the future. The process is child-led, and through the process, children are asked to consider ethical aspects such as fairness and privacy. For instance, in one of the workshops, they will design a teacher of the future, from the physical form of the teacher to the technical features and roles, and discuss the teacher's responsibility. How will the teacher grade and assess students in a classroom? Is it based only on